Lesson objective for this video, students will find the sum of interior angles of a polygon, use the sum to classify the polygon, and find unknown angles. So if we have a polygon that has 3 sides, it's called a triangle. And so how many triangles do I have here? I have only one. And so the sum of the interior angles is 180 degrees because the angles of a triangle always add up to 180. All right, if it has 4 sides, the general name for it is a quadrilateral. And so if I draw a line from one of the vertices here, I can draw a diagonal, and when I do that, I have 2 triangles. And so the sum of the interior angles is going to be 2 times 180, or 360. If a polygon has 5 sides, it's called a pentagon. So again, if I draw lines from one of the vertices, now I have 3 triangles, and 3 times 180 is 540 degrees. Alright, so if I have 6 sides, then I have a hexagon. So again, I can draw diagonals from one of the vertices. And now I end up with 4 triangles. 4 times 180 is 720. So the sum of the interior angles of a hexagon would be 720 degrees. If it has 7 sides, then it's called a heptagon. So now if I draw my diagonals, I have 1, 2, 3, 4, 5 triangles inside of my heptagon. And 5 times 180 is 900. So the interior angles of a heptagon add up to 900 degrees. And the last one we're going to do is an octagon. So once again, if I draw my diagonals, now I have 1, 2, 3, 4, 5, 6 triangles. And 6 times 180 is 1080. So at this point, hopefully you're noticing a pattern. If I have n number of sides, I'll call that an n-gon. And if I were to draw the diagonals from one vertice, how is the number of sides related to the number of diagonals? When I had 4 sides, 2 diagonals, 5 sides, 3 diagonals, 6 sides, 4 diagonals, and so on. So what are we doing? We're just subtracting 2. So the number of diagonals is n minus 2, or number of triangles rather. And so the sum of my interior angles, I just have to take that n minus 2, whatever the sides were, subtract 2, and multiply that times 180. So just to give a specific example, suppose I have something with 15 sides. There isn't a special name for that. We just call it a 15 gon. So 15 minus 2 is 13. So to find out the sum of the interior angles for a 15 gon, I just take 13 times 180. And that comes up to 2340. So the sum of the interior angles of any polygon is the number of sides minus 2 times 180. So that is a formula that you should memorize. Make yourself a flashcard, do whatever you have to do to memorize that. And a diagonal, just so we have a definition, a diagonal is a segment that joins two non-consecutive vertices. It joins two non-consecutive vertices. And just a corollary to that, if we have a quadrilateral, we know that the interior angles of a quadrilateral are always going to add up to 360. So we've got some examples where we're going to use this formula. We're going to find the sum of the measures of the interior angles of a convex nonagon. So if it's a nonagon, then that means it has 9 sides. And so the sum of the interior angles is just going to be 9 minus 2 times 180, which is 7 times 180. And so that would equal 1,260. Okay, so on your own, why don't you try finding the sum of the measures of the interior angles of a convex dodecagon. Pause the video now. Okay, so we're talking about a dodecagon, do meaning 2, deca meaning 10, so n is 12. So you just do 12 minus 2 times 180, or 10 times 180. And so hopefully you got 1800 when you did that yourself. Another example for your notes, we can find the sum of the interior angles of a convex decagon. This time I have only a decagon, 10 sides. And so 10 minus 2 times 180 would be 8 times 180. And that comes out to 1440 degrees. So if I add up all the angles on the inside of a decagon, it's going to be 1,440 degrees. Okay, so I've got one more for you to try on your own. Find the sum of the interior angles of a convex 17-gon. Pause the video now. Okay, so you would have done 15 times 180, and you should have gotten 2,700 degrees. Another example, the sum of the measures of the interior angles of a convex polygon is 900 degrees. We're going to classify the polygon by the number of sides. So now we have to work backwards. We have to figure out how many sides the polygon has. So I know that the sum is equal to n minus 2 times 180. So in this case, they told me the sum was 900. So to solve this, you could do the distributive property, but since we want to get the n alone, it's actually going to be quicker if we go ahead and just divide out the 180 from both sides. So if I divide both sides by 180, 900 divided by 180 is 5. And then they cancel out on this side. So 5 is equal to n minus 2. So you just add the 2 to both sides, and you get that n is equal to 7. So if it has 7 sides, it's called a heptagon. And so your answer would be heptagon. I'd like you to try this next one on your own. The sum of the measures of the interior angles of a convex polygon is 1620 degrees. Classify the polygon by the number of sides. Pause the video now and do the problem on your own. Okay, hopefully you got that you had an 11gon. Now we're going to talk about exterior angles. Exterior angles are angles that are on the outside of our polygon. The sum of the measures of the exterior angles of a convex polygon is 360 degrees. And it will always be 360 degrees, no matter how many sides the convex polygon has. And that's with one angle at each vertex. That's important that you realize it's only one angle. We're not drawing 2 lines coming off of each corner, but just one. So for example, if I have a problem such as this, I can solve for x because I know the sum of my exterior angles is 360. So x plus 89 plus 2x plus 85 has to add up to 360 degrees. So if I combine my like terms, I've got x and 2x, which is 3x, and then 89 plus 85 is 174, and that has to equal 360. I subtract 174 from both sides, and then I'm left with 3x is equal to 186. Divide both sides by 3. And we get that x is equal to 62. So in the past, we learned that a regular polygon is convex, and it has congruent sides, and it has congruent angles. So if all the interior angles are congruent, what do you think is true of the exterior angles? Oh, they're congruent too. So therefore, the exterior angles are congruent as well. Okay, so now we have an example. We're going to find the measure of an interior and an exterior angle of a regular hexagon. So first, let's take a look at our interior angles. I know that all of them together, the sum is 180 times n minus 2. So if it's a hexagon, 6 minus 2 times 180, which is just 4 times 180, or 720. So all of them all together are 720 degrees. But if I want to know what just one interior angle is, and of course this is a regular hexagon, so that means they're all congruent. So one interior angle is just going to be 720 divided by 6. It's just going to equal the sum altogether divided by the number of sides. So in this particular case, 720 divided by 6, and so each of the interior angles is 120 degrees. With our exterior angles, then the sum is always equal to 360, no matter how many sides I have. So just one exterior angle is just going to be 360 divided by the number of sides. So in this case, we would have 360 divided by 6, and so they equal 60 degrees. So what do you notice about 120 and 60? What do they add up to? They add up to 180, which is what you would expect. Because if I have my exterior angles, here are all my exterior angles on my hexagon. And so if I look at my interior angle here, I found that it was 120, and my exterior angle was 60, and that's what we would expect because together they make a linear pair, and so they are supplementary. So actually, once you have found one of them, then it's really easy to find the other one. You just subtract it from 180. So you can do either one. You can find the interior angle first and subtract it from 180 and find the exterior angle, or it's actually a little bit quicker to find the exterior angle, subtract from 180 and find the interior angle. So I've got another example for you to try on your own here. Okay, so we're going to find the interior and exterior angle of a regular nonagon. So this time, try finding the exterior angle first. A nonagon has how many sides? 9. So you just take 360 divided by 9, and so the exterior angle is equal to 40 degrees. Therefore, the interior angle is just 180 minus 40, so it would equal 140 degrees. Okay, and another one. This one I'm going to totally let you do it on your own. Find the exterior and interior angle for a 24gon. Pause the video now. Okay, so hopefully you got that the exterior angle was 15 degrees and the interior angle was 165 degrees. That concludes this video. Thank you.